everyone, hope you are all fine, and I hope that you could understood the last videos about the Kirchoff rules and the Kirchoff first law. Okay, today we are going to discuss about the Kirchoff second law. Okay, so the Kirchoff second law is also called as loop law. Why it is also called as loop law? Because it is applicable for loops. Okay, Kirchoff first law is applicable for, yes, it is applicable for the junctions. Here it is applicable for the loop. So it is called as loop law. Okay. Why it is called as voltage law? Because it is dealing with the voltages. It deals with the voltage in the circuit. So it is called as voltage law. So Kirchoff's second law, loop law and voltage law all are same. Okay. What does this law says? This law says in any closed circuit, the algebraic sum of potential difference across different element is 0. Okay, if you take this circuit, okay, so when there are three elements are there, it is two cells and one resistor. Okay, so if you take the potential difference across this cell, this resistor and this cell, when you add up all these values, you will be getting 0. புரியுதா? இந்த மூணு எலிமெண்ட்ஸ்க்கும் across a potential difference measure பண்ணி அதை add up பண்ணீங்கன்னா you will be getting a value 0. That is called as Kirchoff second law. Okay, so before going when we take this, in some point why we are calling it as algebraic sum. So at some point it will be positive and some point it will be negative. Okay, so before going to apply this, okay, we have to study about the directions, how to calculate. Okay, we have to learn how to calculate this, that is voltages, potential difference, that is algebraic sum, how to calculate it. There are certain rules. Okay, there are certain steps to do it. Let us see one by one. This current direction in all elements, we have to assume, suppose I have taken only 3 elements. Okay, 2 cells and 1 resistance. Okay, so first you have to distribute, that is we have to consider the current direction for all the elements. Okay, that means we have to distribute the current. Okay, we can start it from any point, எந்த இடத்துல இருந்து வேணாலும் start பண்ணலாம். Okay, for our convenience I am starting from this point. Okay, so this is positive and this is negative. We know that current will always flow from higher potential to lower potential. Okay, so for this flow I am consider this current as I1. Okay, so this is I1. புரியுதா? இங்க இருந்து current வரதா எடுத்துக்கிறேன். So this is I1 and it is meeting at this junction. This is the junction. We know that 3 point meet ஆகுது இல்லையா? அந்த இடத்தை we will call it as junction. Okay, so when it comes here, it meet at this junction. This is I1. Okay, also you always keep a point in mind, that is in a single branch, in a branch at all the point the current will be same. அதாவது இது ஒரு branch இல்லையா? நமக்கு தெரியும் branchனா ஒரு ஜங்ஷன்ல இருந்து இன்னொரு அடுத்த ஜங்ஷனுக்கான அந்த பாத்தை தான் we will call it as branch. So இந்த branchல எந்த இடத்துல நீங்க பார்த்தாலும் the current will be I1 only. Whatever the point may be, the current will be I1 and it is in this direction. Okay, when you consider this one, okay, now let us take this cell. Okay, in this cell what will be the direction of current? It will be like this. Okay, I am taking it as I2. It is going here and reaching this junction, it is I2. So in the cell எந்த இடத்துல நீங்க பாத்தீங்கனாலும் you will be getting the current, it is I2. Okay, clear? Okay, then the third element, when you consider the third element, you can see, you can use Kirchoff first law over here. Okay, at this junction I know that current entering is equal to current leaving, right? So here the entering current is I1 plus I2. So what will be the resultant here? Here it is I1 plus I2 because entering is equal to leaving. Okay, so this is I1 plus I2. So இந்த இடத்துல இந்த இடத்துல வர நான் எங்க பார்த்தாலும் I will be getting what current? I1 plus I2. Suppose this is 3, this is 2, at whatever the point may be, I will be getting the current as 5. Okay, now when you see this junction, I can find out that here also I1 plus I2. When it is splitting, we can write it as at junction B. Okay, at junction B what will be my value? Entering equal to I1 plus I2, leaving equal to I1 plus I2. So my distribution is correct. There is no problem. Okay, so the first step is over. We have distributed the current. Okay, the next step is we have to consider the direction of current. Okay, first to distribute the current. We can take this as the first step, distribute the current and assume the direction of current. Okay, to find out the direction of current, there are some key things. Okay, that is like a tricks. Okay, you have to follow that key so that it it will be easier for you to do all the numericals. Okay, so try to follow this trick. Direction of current, there are certain rules. So for our calculation, okay, the circuit may be in circuit in the மாதிரி இருக்கும் இல்லையா, இப்படி இருக்கும். It will be coming like this, it will be going like this. Okay, so it will be, the direction will be changing. Okay, so இந்த மாதிரி நீங்க loop follow பண்ண இருக்கும்போது, so either you can go from right to left or from left to right. Okay, for example, I am taking this one branch. Okay, it is having a cell. Okay, இந்த மாதிரி ஒரு cell இருக்கு, that is one branch. We know that what is the current direction here, it will be in this direction. Okay, because positive to negative, so this is my current direction. Okay, but now in the direction la calculate பண்ணிட்டு போறேன் அப்படினா, we can select a loop. Okay, we can select a loop and we can either calculate in clockwise direction or we can calculate in anti-clockwise direction. Two ways of calculations are there. ஒரு loop select பண்ணும்போது clockwise la போயும் நீ calculate பண்ணலாம், இல்ல anti clockwise direction லையும் calculate பண்ணலாம். Both the directions if you calculate you will get the same answer. Okay, so we are considering about these two cases. எப்படி எடுத்தாலும் என்ன மாதிரி நீ அஸ்யூம் பண்ணனும் அப்படிங்கறது தான் நம்ம இங்க பார்க்க போறோம். This is very very important. புரியுதா? இந்த லூப் நீ இந்த வழியில போனாலும் சரி, இல்ல இந்த வழியில clockwise anti clockwise ரெண்டுக்கும் எப்படி யூஸ் பண்ணனும் அப்படிங்கறத பார்ப்போம். For example, I am taking a cell. Okay, actually the current direction will be in this direction, but my loop direction, நான் எடுத்த direction, நான் clockwise direction எடுத்திருக்கேன் அப்படினா நான் இப்படி போயிட்டு இருக்கேன். My calculation is in this direction. Now we can see both the directions are opposite to each other. So at that time we have to write the potential as minus sign. சரியா? அந்த டைம்ல அதுல இருக்கிற பொட்டன்ஷியலை நம்ம எப்படி எடுத்துக்கணும்? மைனஸ் னு எடுத்துக்கணும். Keep easy it is. ரெண்டுமே opposite directionல இருந்துச்சுனா you have to take that potential as minus. Okay, இல்ல இப்படி ஞாபகம் வச்சுக்கலாம். Okay, நீங்க இந்த உங்களோட current direction இப்படி இருக்கு இல்லையா? Okay, let it be. Okay, so when both the directions are opposite, you can write it as minus. Okay, so from here you can see from B to A, here from A to B, that is our calculation is from A to B. Here our calculation is from B to A, but current direction you can see it is from A to B. Okay, so you can see that I have made a mistake. This is minus and this is plus. Okay, so my current direction is also, my calculation is in this direction, my current direction is also in the same direction. When these directions are same, we can take that EMF as, that potential as plus. புரியுதா? எப்போ direction opposite இருக்கு, நீ போற directionம் அங்க இருக்கிற directionம் opposite இருக்கும்போது you can take it as minus. ரெண்டும் ஒரே directionல போச்சுனா we can take it as plus. Okay, clear? This is for cell. The next one is for resistor. This is one branch of resistor. Okay, we consider that the current is flowing in this direction. In the resistor la in the direction la current flow, and the circuit la in the direction la current flow irukkudu, but you are calculating in the same direction. So I already told that when they are in the same direction we can write the potential as V is equal to IR, so it is plus IR. Okay, now here we can see, here the current is in this same direction, it is going from A to B, but you are calculating, உன்னோட calculation எங்க இருக்கு, B ல இருந்து A நீ வர்ற அப்படினா both are in opposite directions, so what happens, my formula will be V is equal to minus IR. Okay, so these things you have to consider while solving the problems. It is very important. This question may be asked for 3 marks also. They will ask the rules. Okay, what are the rules to be, or what are the sign conventions to be followed while analyzing using Kirchoff's second law. These are the sign conventions. புரிஞ்சுதா? நீ எடுக்கிற directionம் current directionம் same ஆ இருந்துச்சுனா plus, நீ எடுக்கிறதும் அதுவும் opposite ஆ இருந்துச்சுனா minus. That's all. So hope that you can understood both the current law and the voltage law, or both the first law and the second law of Kirchoff. Okay, it is very very important. In the next lecture we can see about the applications of these Kirchoff law. Thank you for watching.